The first time the Hubble Space Telescope turned its steady gaze toward the object now called 3I Atlas, the data came back with something no one had predicted. What should have been a silent traveler made mostly of rock, metal, and frozen carbon dioxide appeared to be doing something alive, shedding faint ribbons of water vapor as it crossed the dark between Mars and Jupiter. Even for astronomers who have spent entire careers studying comets, that detail was quietly stunning. The story of 3I Atlas began long before this moment, long before Hubble's instruments captured those unexpected spectral lines that whispered of liquid molecules breaking free in sunlight. It started in another star system, perhaps one born billions of years ago, where ice and dust clung together around a young star's glow. At some unknown point, a gravity dance went wrong, and the small body was thrown outward, beyond its home star, beyond its planets, into the wide emptiness that links galaxies together. For ages beyond counting, it drifted. No sun, no warmth, no reason for change. Then, in the year humans called 2025, telescopes here picked up something moving strangely fast through the outer solar system. It wasn't bound to the sun the way planets and comets are. Its path curved only slightly, then pointed straight back toward the Milky Way's deep arm. Scientists named it 3I Atlas, the third known interstellar visitor, after Oumuamua and Borisov. Discovered by the Asteroid Terrestrial Impact Last Alert System, the wide-eyed survey scanning our skies each night. Most comets are icy relics left from our own system's early days. They behave predictably. Sunlight heats their surfaces, ice turns to gas, and a shining tail stretches out behind them. But 3I Atlas defied those familiar patterns from the start. When the European Space Agency's observers at the Very Large Telescope caught their first glimpse, they expected the same telltale mixture of water vapor and dust. Instead, the spectrograph lines told a different story: intense carbon dioxide emission and an odd lack of water. Weeks later, when Hubble joined the watch, its ultraviolet sensors added a layer of surprise. Hidden in the spectrum were delicate traces of water molecules, fainter than any comet of similar brightness, yet unmistakable. Where could that water be coming from if the outer layers were dominated by carbon dioxide ice? To the listener trying to imagine it, think of a frozen world the size of a small mountain, spinning slowly through space. One side faces the distant sun, warming just enough that ancient ice sealed under dusty crust begins to crack. Thin jets escape, curling like vapor from a cup of tea in the cold air. Each particle of water dances into vacuum, then instantly crystallizes, joining a faint, shimmering halo around the traveler. That soft halo, invisible to most telescopes, glowed only when Hubble and ESA instruments combined their light to tease out its secrets. Astronomers love mysteries that begin with numbers and end in wonder. In early reports released by ESA's Planetary Science Division, researchers explained that the comet's ratio of carbon dioxide to water was more than 7-to-1, higher than anything seen before. Typical comets from our solar system are rich in water, frozen since the sun's birth. Yet here was a wanderer from another system whose chemistry told a different story. Perhaps it had formed farther from its parent star, in a place where even carbon dioxide could freeze solid. That possibility filled observatories across the world with quiet excitement. If confirmed, it meant 3I Atlas carried within it the chemical fingerprint of a whole other planetary nursery, a time capsule from an alien dawn. But the water posed a puzzle. Hubble's detection wasn't a measurement error. Multiple instruments confirmed the faint emission lines of hydroxyl radicals, the fragments left when sunlight splits water molecules apart. It was real. Somehow, this dry interstellar rock was breathing out moisture. Scientists from the European Space Agency and NASA's Goddard Space Flight Center began comparing notes. Maybe, they proposed, the water came not from surface ice but from minerals, hydrates, that trapped molecules deep within. When the comet warmed, those minerals released their ancient cargo. Others suggested tiny impacts by micrometeorites could knock water free, or that radiation from eons of interstellar travel had created new compounds, now breaking apart. None of these explanations fit perfectly. And that imperfection, that small gap between what was known and what was seen, is where curiosity lives. Imagine being one of the astronomers in the early hours of that discovery. The control room is dim except for screens showing spectra, thin colored lines and spikes that most of us would overlook. Somewhere between them, a shape begins to appear, the signature of water. Someone leans closer, then another. A hush falls. Data streams in silence for minutes, hours. In those quiet spaces, science feels like listening to the universe breathe. What makes this even more beautiful is how cooperative the universe can be when patience meets technology. The James Webb Space Telescope joined the effort later, confirming that the water emission wasn't constant. It flickered, waxing and fading as the comet rotated, suggesting active regions on its surface. That rhythm, light, fade, light, was like a heartbeat. For a world wandering alone for billions of years, it was strangely poetic. As the findings reached the public, headlines spoke of unexpected water and cosmic surprises. But within observatories, the conversation turned deeper. What could 3i Atlas teach us about our own beginnings? If interstellar visitors carry ingredients similar to those that seeded Earth's oceans, then perhaps water is not rare at all. Perhaps every star system has its own ocean waiting in potential, scattered among icy fragments drifting through the dark. Even skeptics who once dismissed the object as just another rock began to reconsider. The European Southern Observatory released processed images showing a faint greenish hue surrounding the comet, caused by excited carbon molecules. That glow, mixed with the new evidence of water, created an image both scientific and strangely emotional, a symbol of how chemistry becomes beauty when seen from the right distance. Throughout the weeks that followed, astronomers continued watching. They measured the object's rotation about 17 hours for a full spin. They tracked its path, a gentle sweep inclined only a few degrees from the planetary plane. It was as if this visitor had chosen a route designed to pass through our view without disturbance. Late one night, when the data from ESA's Comet Interceptor project arrived, researchers noticed a small but steady increase in the water emission rate. It was minor, barely measurable, yet it meant something was changing on the comet's surface. Tiny jets were becoming active, proof that even after endless cold, sunlight could wake ancient ice. If you close your eyes now, picture that scene in your mind, a lonely traveler gliding between worlds, illuminated by the distant sun. From its surface rise thin whispers of vapor, curling into space like sighs. Hubble floats high above Earth, its mirror catching those faint traces, translating them into colors humans can read. On another side of the planet, ESA's instruments listen too, turning invisible light into knowledge. Two machines, two agencies, one shared moment of discovery, all directed toward understanding something that has crossed unimaginable distances to visit us. This is what makes 3i Atlas more than an object. It's a conversation between worlds. And as scientists often say, when they reach the edge of certainty, this is where the fun begins. Because each answer about 3i Atlas, its composition, its orbit, its quiet emissions, leads to another question. Why does the water come in pulses? Why so little hydrogen? Could radiation from interstellar travel have changed its surface, baking away lighter elements while preserving deeper ice? No telescope can yet see inside it, but new missions are already being planned. ESA's upcoming Comet Interceptor hopes to one day intercept a similar interstellar object, to fly beside it and watch directly as sunlight stirs ancient materials. If 3i Atlas had arrived a few years later, it might have been that mission's first target. Still, even from afar, it has become a teacher. Every spectrum recorded adds a small note to humanity's growing symphony of cosmic understanding. And in the end, perhaps the greatest wonder is not what 3i Atlas is made of, but what it reminds us about ourselves. that curiosity is our way of staying connected to the universe. If you're listening to this story as you drift towards sleep, let that thought settle gently. Somewhere above you in the Black Sea beyond the planets, a small traveler glides and exhales faint water vapor into space. Hubble watches quietly, ESA listens. The Earth turns. And in that turning, questions become lullabies for those who love to wonder. The more the telescopes watched, the stranger the rhythm of that vapor became. It wasn't random. The water emissions pulsed, as though tied to the object's slow spin, each rotation revealing a slightly different heartbeat. Astronomers mapped the pattern carefully, hour after hour, night after night, and realized that the bright jets were aligned along what appeared to be fissures in the surface crust. Something beneath those cracks was waking, melting, releasing. That observation changed the tone of the conversation inside the research centers. It meant that the 3I Atlas wasn't inert. It was active, responding to the sunlight in a way no one had predicted for a body thought to have spent billions of years in interstellar cold. What surprised people most was the faint steadiness of the signal. The emissions weren't violent or chaotic. They were measured, consistent, and almost gentle. It's a little like finding a forgotten seed that still sprouts when placed in warm soil. The chemistry of 3I Atlas had slept for ages beyond memory, yet the moment it brushed against a star's light, life of a kind returned to its frozen heart. That image, quiet and patient, touched many of the scientists following its journey. They began describing it less as an object and more as a messenger. From the data shared between the Hubble team and ESA's Infrared Space Observatory, researchers pieced together a layered picture of the comet's surface. They found that the outer crust was darker than expected, coated in organic compounds that absorbed sunlight efficiently but released it slowly. Under that crust lay strata of volatile ice, mostly carbon dioxide, but streaked with traces of water locked inside crystalline grains. When a fracture exposed those hidden pockets, the sun coaxed out the vapor. So the unexpected water emissions that made headlines weren't proof of life or machinery or alien design. They were proof of memory. 3I Atlas remembered warmth in a chemical sense from another world. Each puff of vapor was a breath of that ancient place. To make sense of such delicacy, the scientists adjusted their instruments to the softest sensitivity. They treated the comet as you might treat a wild bird that has flown unexpectedly into your home, carefully, respectfully, watching without frightening it away. The measurements were taken with long exposures and minimal interference, letting photons gather on detectors like morning dew. And as they gathered, a pattern of color appeared. The emitted water reflected sunlight through the surrounding dust, creating a faint halo tinted with blue. It was barely visible in the raw data, but when processed, the effect was unmistakable. This wasn't the bright emerald glow of carbon molecules. It was subtler, like a breath frozen in air. One researcher compared it to the way the northern lights shimmer above Earth. Another said it reminded her of seeing frost melt on a window pane when she was a child. Those human comparisons, drifting through technical reports, said more than the numbers could. They revealed how this distant traveler was reshaping not just equations, but imaginations. Hubble's role in all of this cannot be overstated. Orbiting above Earth's turbulent atmosphere, it captured spectra so pure that they could isolate the signature of single molecules. ESA's ground-based telescopes, meanwhile, provided the context, the size of the coma, the rate of dust release, the angle of sunlight. When those pieces were combined, scientists could model the object's environment in 3 dimensions, watching in simulation as sunlight traced across its face. In those visualizations, 3I Atlas drifted like a dim coal in endless darkness, one side glinting faintly, the other disappearing into shadow. The jets of vapor formed temporary arcs curling into space before fading. No one knows exactly how much water it released, but the estimates, tens of kilograms each second, are modest compared to local comets. And yet, against the backdrop of the interstellar void, even a trickle of water feels like abundance. As the months went by, the Hubble and ESA teams exchanged quiet messages about timing their next observations. There was no rush. The comet was expected to remain visible for nearly a year, giving them time to watch its slow approach toward the Sun. With every rotation, it revealed another clue, another shimmer of physics that belonged neither entirely to our solar system nor fully beyond it. This is what science looks like when seen from up close. Not grand pronouncements, but patient listening. Each line of data becomes part of a conversation stretching across light years. The water emissions of 3I Atlas whispered that the boundaries between star systems are not walls but bridges, that matter and memory travel freely through the galaxy. If you imagine yourself floating there beside it, no sound, no wind, what you would see is simplicity itself. A dark, irregular shape turning slowly. From its surface, faint threads of vapor rise and vanish. Behind it, sunlight catches tiny grains of dust that glitter briefly before drifting away. There is no engine noise, no gleam of machinery, nothing dramatic, just the steady rhythm of chemistry awakening under light. For the teams at ESA and NASA, that quietness was the most beautiful revelation. It meant that the universe still holds surprises that don't shout. They arrive softly, requiring patience and humility to perceive. Every press release, every headline about unexpected water was, at its heart, an invitation. Look closer, listen longer, wonder gently. Because sometimes the smallest signals, those faint, almost silent traces of vapor, carry the deepest meaning. They remind us that water, the molecule that cradles life, is not ours alone. It is the handwriting of creation, etched again and again across the cold expanse. And that is how Section 1 closes, a scene of patient discovery, of instruments tuned to the quietest notes in the cosmic symphony. Hubble and ESA's telescopes hum softly in orbit and on mountaintops, tracing the breath of a traveler from another sun. Somewhere in that delicate exchange between light and ice lies the reason we keep watching the sky, because each time we do, we learn not just about the stars, but about the part of ourselves that still loves to be amazed. The story of 3I Atlas deepened as weeks turned into months. What had started as a simple investigation of a curious object became a slow unfolding of cosmic detail, each observation peeling back another thin layer of mystery. The water emissions that Hubble and ESA had detected didn't remain steady. They fluctuated with rhythm and patience, rising and falling as if breathing with the sunlight itself. Astronomers noticed that every time the comet turned one full rotation, the faint traces of water brightened on one side, dimmed, and then appeared again, almost perfectly timed. The realization spread quietly among research teams. 3I Atlas might have localized patches of ice hidden beneath its dusty shell, awakening only when sunlight reached those particular regions. This meant the object wasn't just a lump of rock and ice, it had character, variation, a landscape of its own. In laboratories and control rooms, those who followed the data began to treat the object almost like a personality. Someone described its rotation as calm and deliberate. Another said the emission cycle felt like a sigh every few hours. Those words were half jokes in emails between colleagues, but they captured something true, the sense that this distant body was participating in a conversation none of us had expected. The European Space Agency's spectrometers continued to record the unique chemical balance within the vapor cloud. The dominant carbon dioxide signature remained, but the water line persisted, stubborn, delicate, undeniable. With every pass, the software refined the signal, filtering noise until the pattern stood clear. There was no mistake, the vapor was real. What made the discovery so striking wasn't just its presence, but what it implied. For decades, scientists had assumed that interstellar objects, those born around other stars, would show wildly different chemistry depending on the conditions of their home systems. The high carbon dioxide ratio of 3I Atlas had already suggested a world formed far from its star, in a place colder than any region in our solar system. Yet the water told another story. It meant that no matter how alien its birthplace, the ingredients for liquid, for oceans, for possibility were the same. Across the Atlantic at NASA's Goddard Space Flight Center, researchers compared the data with similar readings from previous comets. They noted something almost poetic. While the intensity of Atlas's water emissions was weaker than average, the purity of its spectral signature was unmatched. There were no complex organics muddying the reading, no interference from secondary gases. Just clean, crisp bands of light marking hydrogen and oxygen, the simplest, most familiar duet in the cosmos. That purity fascinated them. It was as if the object had preserved a kind of primordial simplicity, untouched by the contamination of newer elements or cosmic dust. When the findings were presented at a quiet conference in Geneva, a scientist described 3I Atlas as a message from the galaxy's early childhood. Outside the world of research, most people never read the technical reports or saw the raw data. They saw the images instead, those beautiful processed composites showing the comet's faint halo glowing softly against the black. The public imagination is filled with comparisons, a frozen lantern adrift between stars, a messenger carrying whispers of another world. The idea that this unassuming traveler could teach us about the birthplaces of water, perhaps even the origins of life itself, spread quietly, like ripples on a still pond. But for the scientists, wonder existed side by side with rigor. Each new clue raised new questions. Why did the water emissions appear stronger in ultraviolet observations than in visible light? Why were they not accompanied by corresponding increases in dust output, as would normally happen when surface ice sublimates? Could the water be emerging from within, filtered through fractures rather than boiling off the surface? ESA's thermal modeling teams ran simulations for weeks. They built digital replicas of 3I Atlas, adjusting spin rates, surface materials, and solar heating angles. Eventually, one pattern began to match the data, a thin crust of dark organic matter acting like insulation, with pockets of volatile ice trapped below. As sunlight warmed one side, gases built pressure until they found escape through microscopic cracks. The resulting plumes were weak but continuous, explaining the gentle rhythm of emissions. This subtle mechanism became known as cryogenic respiration among the team, a poetic phrase that stuck, even though no official paper used it. It captured the image of the comet breathing through its fractures, exhaling ancient water into the vacuum. Meanwhile, the Hubble Space Telescope continued its vigil. Orbiting far above Earth's haze, it recorded faint shifts in the object's brightness and compared them to ESA's readings. The collaboration between the two agencies felt unusually harmonious. No competition, no territorial claims, just shared curiosity. One astronomer later wrote in her log, "It felt as though both telescopes were two eyes of the same mind, watching something extraordinary." And extraordinary it was. By the time 3I Atlas neared the orbit of Mars, the combined data from Hubble and ESA revealed a new detail. The temperature of the gas near the surface was far lower than expected. That meant the sublimation process was happening more slowly than on normal comets, almost delicately, without the violent jets that often tear small bodies apart. The traveler was conserving itself, unraveling its secrets carefully, as though aware that eyes were upon it. This measured behavior gave scientists a rare opportunity. For once, an interstellar object was stable enough to study over months rather than weeks. It didn't tumble wildly or fragment. It held its course, steady and consistent. And that steadiness became the canvas upon which the universe painted its faintest watercolor strokes, shades of carbon, traces of water, whispers of dust. If you could step outside of your room right now and look up, past the clouds, past the atmosphere, into the real black of space, you would not see 3I Atlas with your eyes. It's too faint. But you could imagine it there, a grain of light moving through the solar wind. Around it, invisible molecules of water expand into silence, each one a ghost of another world, another sun. Hubble's mirror catches them, turns their flight into numbers. ESA's spectrometers translate them into meaning. Humans, tiny and brief, listen. What makes this story gentle isn't only its pace, but its promise. The water that leaves 3I Atlas today will drift through our solar system for centuries, its atoms scattering among planets, perhaps someday falling into Earth's atmosphere as faint cosmic rain. The idea that something from another star could one day touch us, not as invasion, not as spectacle, but as a single drop, is the kind of thought that makes the universe feel tender. And so the astronomers kept watching, each new observation a note in a lullaby of science. In those quiet exchanges between orbit and Earth, between instruments and minds, humanity's oldest dream replayed itself. To look up and find a reflection of our own story among the stars. That, they realized, was the real discovery. Not that water existed far away, but that curiosity could carry across such distance and still sound like wonder. Section 3 will continue this same flow following Hubble and ESA's next findings as 3I Atlas approaches perihelion. When 3I Atlas began to drift closer to the inner edge of the solar system, the tone of the research community changed. What had been a distant, serene observation was slowly becoming a moment of history. The Hubble Space Telescope and the European Space Agency's network of observatories were no longer just collecting quiet data. They were witnessing something that would reshape how we think about interstellar matter and water in the cosmos. Each day brought in new readings, and each reading revealed a new subtlety. The water emissions detected months before hadn't disappeared. They were evolving. The vapor seemed to increase in density as the comet warmed, but its pattern remained oddly disciplined, pulsing with the same rhythm as before. This strange consistency puzzled everyone. Usually, when comets move closer to the sun, they flare up dramatically, releasing clouds of gas in chaotic bursts. But the 3I Atlas was calm, measured, graceful. The Hubble Space Telescope's ultraviolet spectrograph was tuned to watch the faint lines that betrayed water's presence. It wasn't the bright, dramatic kind of emission seen from comets like Halley or Hale-Bopp. Instead, it was like a whisper, just a faint shimmer of energy where photons collided with escaping molecules. The Hubble operators, some of whom had worked on hundreds of targets before, described the data as delicate and mysteriously alive. There was an elegance in how the object released its water, almost as though it were conserving energy, revealing itself only when necessary. Meanwhile, on the ground, ESA's very large telescope in Chile and the infrared telescope facility in Hawaii were adding their voices to the cosmic chorus. The collaboration stretched across continents and time zones. When it was day in Hawaii, it was night in Chile, allowing almost continuous observation. Teams handed off data to each other like careful runners in a relay, each adding another layer of understanding. What they saw was a comet that seemed to be teaching them patience. Rather than giving up its mysteries all at once, 3I Atlas shared them piece by piece, like chapters of a book written in the language of light. One late night, an ESA astronomer named Carla Duver was analyzing a sequence of spectra when she noticed a faint pattern of repeating spikes. They weren't random. They appeared every 16 to 17 hours, exactly matching the object's rotation period. She sent a quiet message to her colleagues. "It's breathing again." The phrase caught on within the team. Each cycle of emission became known as a breath, the rhythm of a world speaking across the void. As the comet approached its closest point to the Sun, or perihelion, scientists prepared for possible fragmentation. Many comets don't survive this phase. The heat, the gravitational stress, the constant bombardment of solar radiation all can tear a small body apart. But once again, 3I Atlas defied expectation. The object brightened slightly, yes, but it remained intact. Its shape, though irregular, showed no signs of splitting or crumbling. This resilience led some to call it the quiet survivor. The Hubble ESA joint report released soon after noted that despite the increasing solar heat, the water emission rate rose only gently by no more than a few percent. It was as if the object had found a perfect balance between release and retention. Too slow to evaporate completely, too warm to stay entirely frozen, it lived in the delicate in-between. That balance fascinated planetary scientists because it hinted at the physics of worlds born under other stars, where the chemistry of ice and rock might play by different rules. At ESA's data center in Darmstadt, analysts began comparing Atlas's emission data to computer models of distant star systems. They simulated what the environment might have been like billions of years ago when 3I Atlas first formed. Some models suggested it was born near the carbon dioxide frost line, a boundary in the protoplanetary disk where temperatures were low enough for carbon dioxide to freeze, but too cold for water to form ice easily. Others argued it might have migrated inward at some point, collecting traces of water from warmer regions before being ejected by a gravitational encounter. Every hypothesis added new dimensions to the mystery, and through it all, the comet continued its silent journey, releasing its vapor in disciplined waves. For those listening from Earth, the story had become strangely personal. People began to describe the 3I Atlas as if it were a visitor who had come to remind us of something ancient, that the building blocks of life were not confined to one world. The discovery of water around an interstellar object confirmed what astronomers had long suspected. Water is not a local phenomenon. It is a universal traveler. At the same time, there was humility in that realization. The amount of water being released was small, almost laughably so by earthly standards, barely enough to fill a household swimming pool over months. But that wasn't the point. It was the fact that any water at all existed, locked inside a fragment that had wandered the galaxy for billions of years, surviving radiation, collisions, and the endless dark. The Hubble team took one final deep exposure before the comet passed behind the Sun. For a moment, the data feed froze as if the machine itself was holding its breath. When the image was processed, it revealed something unexpected. A thin arc of blue trailing the comet's path, faint but clear. It wasn't dust. It wasn't gas. It was reflected sunlight scattered by the escaping water molecules, forming a translucent halo stretching thousands of kilometers across. When the image was shared privately among scientists before publication, silence filled the room. One researcher whispered, "It looks like it's wearing a veil." That veil became a kind of symbol. For weeks afterward, the photograph appeared in journals, presentations, and even as desktop backgrounds in observatories around the world. The halo wasn't just data, it was emotion made visible. It was the moment when science, art, and wonder met in the same breath. And yet, for all its beauty, 3I Atlas was still moving on, still following the trajectory that would carry it out of the solar system forever. By the time it crossed the orbit of Mars again on its way out, it would already be fading from view. The telescopes would lose contact, and the traveler would return to silence. But in that silence, it would leave behind something profound, proof that even the loneliest wanderers of the galaxy carry traces of the same water that fills our oceans and rivers. If you listen quietly, you can almost imagine that traveler now, gliding past Jupiter's orbit, halo dimming, still breathing faintly under starlight. Its path is unchanging, its rhythm calm. Hubble turns its mirror elsewhere. ESA's instruments move to new targets. But somewhere, in the background hum of data and memory, 3I Atlas continues to whisper the same simple truth, that water and wonder are never far apart. And as scientists close their logs for the night, there's a quiet understanding that stories like this don't end. They drift, like the comet itself, from one curious mind to another, carried by the soft current of discovery. As the days rolled by and 3I Atlas slipped deeper into sunlight, something subtle began to happen, a quiet transformation. noticed first by a handful of researchers who had been watching the faint water lines appear and fade on their monitors. The data, steady for weeks, now showed tiny, almost imperceptible variations in wavelength. It was as if the vapor around the comet had begun to shimmer differently, scattering the light in a new way. To most people, these were just numbers, fractions of micrometers, slight deviations from the norm. But to those who had spent months studying this visitor, the change felt alive. They gathered in small groups across observatories, sharing screens, cross-checking algorithms, and rerunning calibration scripts. Eventually, a pattern emerged. The spectral lines of water were splitting into faint double peaks, a sign that some of the vapor was moving at slightly different speeds. It meant that the jets releasing this water were not uniform. They were twisting, spiraling. Something inside the 3I Atlas had shifted. At the European Southern Observatory, an instrument specialist named Thomas described the phenomenon to a reporter as the cosmic equivalent of a whisper turning into a sigh. The metaphor stuck. It fit perfectly because what was unfolding wasn't violent or dramatic. It was delicate, almost intimate. The comet was not breaking apart. It was changing the way it breathed. The Hubble Space Telescope caught this evolution too. Its ultraviolet detectors captured faint arcs of emission curving around the object, faintly blue against the dark background of space. When the data was processed into false color imagery, the pattern became clear. 3I Atlas wasn't releasing water from a single vent. It was releasing it from multiple regions across its surface, each pulsing in rhythm with its slow 17-hour rotation. For the first time, scientists could see not just the chemistry but the choreography. What made it even more fascinating was the temperature. ESA's infrared readings showed that the surface remained colder than expected, even though the comet was much closer to the sun than before. Normally, the warmth of sunlight would heat the crust rapidly, causing chaotic outbursts. But here, the object's outer shell seemed to resist the heat, perhaps due to its dense carbon coating, a black skin that trapped energy without transferring it inward too quickly. Inside, though, things were stirring. Some researchers proposed that the energy from sunlight was slowly working its way beneath the crust, awakening layers of volatile ice that had remained dormant for billions of years. As these pockets expanded, they pressed against the surrounding rock, searching for cracks through which to escape. The result was the twisting jets, the comet's faint sighs. Those sighs carried more than vapor. When ESA's cosmic dust analyzer measured the composition of the ejected material, it found something unexpected: microscopic grains containing traces of ammonia and formaldehyde, simple organic compounds that form in the coldest regions of star systems. These were molecules linked to prebiotic chemistry, the same kinds that scientists believe once seeded the young Earth with ingredients for life. That realization filled the research notes with quiet awe. Here was an interstellar traveler, likely older than the Sun, carrying the same kinds of compounds that may have begun life on our planet. It was as if the universe had been scattering recipes for life across space, letting gravity and time deliver them where they might take root. One researcher in Germany, reading through the early ESA drafts, wrote in her notes, "The story of life might not have begun here. It might simply have arrived." That sentence circulated quietly among the teams. No one used it in a paper. It was too poetic, but it found its way into private conversations, small talks at coffee breaks, late-night messages between astronomers separated by ocean. It wasn't proof, but it was possibility, and possibility has always been science's most powerful fuel. Meanwhile, the public's interest was rekindled. ESA's communications team released a new visualization showing 3I Atlas surrounded by faint plumes rotating under sunlight, the halo of water and dust glimmering like smoke in a spotlight. The video spread quickly online. For a few days, it was everywhere, on news broadcasts, social feeds, even classroom projectors. People found comfort in it. Maybe because it reminded them that the universe, vast and indifferent though it seems, still holds gentle mysteries. Or maybe because, in an age of noise and urgency, there was something profoundly calming about a story that unfolded slowly, over months, not minutes. Back at NASA's Goddard Space Flight Center, a parallel effort began. Teams there analyzed the Hubble data with machine learning models to trace subtle periodicities in the emission cycles. They found something fascinating. The emissions weren't just random flares. There was a consistent interval, a quiet pulse that repeated every 16 hours and 50 minutes, plus or minus a few seconds. That precision stunned them. It was almost too consistent for a natural object, but not impossible. The scientists weren't suggesting any unnatural explanation. They were careful not to, but they couldn't help marveling at how orderly it all was. "It's as if it's playing music," one of them said, half-jokingly, during a live data review. The phrase caught on for a few days, the comet song. Soon, audio engineers working with NASA's outreach department converted the frequency data into audible sound, a low, rising hum with rhythmic pulses representing the measured outflow of water molecules. When played through speakers, it sounded like a heartbeat, slow and distant, with the whisper of wind layered behind it. That recording became one of the most listened to files in NASA's digital archive. People described it as meditative, soothing, almost spiritual. Some said they used it to fall asleep. Others played it while studying or walking. The hum of a faraway comet, transformed into sound, became a gentle reminder that even the coldest parts of the universe hold warmth in motion. Yet, as beautiful as the discovery was, it came with a quiet sense of melancholy. Everyone knew that 3I Atlas was a visitor, not a neighbor. Its trajectory meant it would soon leave our solar system forever, never to return. By the time it crossed the orbit of Mars again, it would fade into darkness, the faint water emissions vanishing into silence. The ESA and Hubble teams prepared their final joint observation schedule. It would be a farewell session, a few last exposures before the comet slipped beyond the reach of their instruments. There was a kind of reverence in the planning, as though they were arranging the final notes of a symphony. One of the mission coordinators described it in her log. "We are saying goodbye to a teacher who spoke without words." When the day came, Hubble turned its lens once more toward the faint traveler. The data streamed down, clean and quiet. The water lines were still there, weak, fading, but unmistakable. The comet had not gone silent yet. In its final days within the warmth of our sun, it continued to breathe, steady and gentle, like a voice carried on wind across light years. And perhaps that's what struck everyone most deeply. The fact that something so ancient and cold could still show grace, could still remind us that change, even the smallest, is its own form of persistence. When the final image was rendered, the halo around 3I Atlas appeared softer than ever. The jets were faint, the light dispersed. But at the center of it all, a tiny core still reflected sunlight, a stubborn glimmer against the void. For a long time, no one in the control room said a word. Then quietly, someone whispered, "It's still shining." And in that moment, everyone knew that the mission, the months of sleepless observation, the data crunching, the careful calibration had been worth it. Because for all the numbers and science, for all the graphs and charts, what they had really found was something deeper. The gentle truth that in the vastness of space, even the smallest traveler can remind us how to look, to listen, and to feel wonder again. The story of 3I Atlas was no longer just about a comet. It was about connection, the way starlight and water, ice and curiosity had crossed distances beyond comprehension to meet in a brief exchange between telescopes and time. And though it was already leaving, it had given us something that would stay, a new way to see the universe, one built not only on observation, but on awe. By the time the calendar reached mid-year, 3I Atlas had drifted into a part of the sky where few amateur astronomers could follow it easily. Most of the large observatories had taken over, their instruments aligned precisely to capture every flicker of light still bouncing off its surface. The faint green shimmer, which had once surprised everyone, was now more subdued, paler, thinner, almost like the final embers of a candle before it fades. But even in that dimness, there was something mesmerizing about it. It still had a pulse. At the European Space Agency's data center in Madrid, scientists watched the spectral graphs update in real time. The long, clean line of water emission, once strong, now appeared dotted and uneven. But those dots told a story. Each fluctuation represented a moment when sunlight touched a fresh patch of ice beneath the crust, causing another brief sigh of vapor. The comet was breathing slower now, but it hadn't stopped. It was like watching a living being at rest, exhausted from a long journey, yet still aware, still steady. Dr. Ana Velázquez, who had been studying 3I Atlas since its discovery, wrote in her notes, "It feels like the object is teaching us patience. We are so used to bursts of discovery, but this is a slow miracle, one that asks us to wait and listen." Her sentiment spread quietly among her colleagues. They began to refer to their observation cycles as listening sessions rather than data runs. The phrasing caught on because it fit the atmosphere of the moment. Studying 3I Atlas no longer felt like measuring, it felt like witnessing. Meanwhile, Hubble's final imaging window approached. Its time was precious, shared among hundreds of projects across the cosmos. But the team managed to secure another narrow slot, a few hours of viewing that could reveal what was happening to the fading traveler as it crossed beyond the inner system. The plan was simple: capture ultraviolet emissions from the trailing jets, analyze the changing brightness of the coma, and compare them with previous spectra to confirm whether the water signals were truly dying out or just shifting in wavelength. But as the telescope's sensors began to record, something unexpected appeared. Instead of a uniform dimming, Hubble detected a faint rise in brightness along the comet's trailing edge. At first, the data analysts thought it might be noise or a reflection artifact. They rechecked the calibration, compared it with control stars in the frame, and the signal held. It wasn't an error, it was real. A new plume had formed. Unlike the others, this one wasn't smooth or continuous. It pulsed faintly, almost rhythmically, releasing bursts of vapor that seemed timed, like a slow heartbeat. The software mapped the pulse intervals and the results were eerie. Each one was spaced roughly 17 hours apart, almost exactly matching the comet's rotation period. In other words, 3I Atlas was releasing water in perfect sync with its own spin. No one could quite explain how. If the vents were unevenly distributed or if one side was more active, the timing would drift over time. But it didn't. The pulses remained steady, mechanical in their precision, as though the comet itself knew when to exhale. When the ESA's team received the same data, they ran independent checks and came to the same conclusion. The emissions were too consistent to be random. Still, there was no need for speculation. The scientists remained calm, rational, focused on finding natural explanations. Some suggested that internal pressure pockets might have aligned with a structural axis, causing regular venting every time the same region rotated into sunlight. Others thought the pattern might be due to an unseen binary fragment orbiting inside the coma, gravitationally triggering outgassing cycles. Whatever the answer, everyone agreed on one thing: 3I Atlas was unlike anything else in recorded astronomy. By now, the public had started following its story again. Science channels and astronomy blogs began running new headlines. The comet that breathes in time. Videos popped up, showing the rhythmic pulses as translated sound waves, deep, spaced beats that seemed to echo across the darkness. People described it as peaceful. They said it sounded like the rhythm of the ocean, the slow inhale and exhale of waves. Some said it made them feel connected to something vast and alive, even if it was just frozen rock and ice drifting between the stars. Dr. Velázquez gave a short talk online to explain the phenomenon. Her voice, soft and calm, carried the tone of someone who knew that the story was bigger than equations. "When we observe something this distant and precise," she said, we're reminded that nature can create order in ways we don't yet understand. It's not magic. It's not a message. It's just beauty we haven't learned to measure yet. The comment spread widely. People quoted it, printed it, even used it in planetarium shows. It captured what so many were feeling, a gentle, unspoken awe. While the comet continued its slow outward path, ESA's infrared sensors detected one more anomaly. The temperature readings from the region around the new plume were slightly warmer than before, not dramatically, but enough to suggest that the surface material had thinned, exposing layers that were richer in volatiles. In simpler terms, the comet was opening itself up. Every spin brought a new breath, every exhalation another wisp of vapor into space. If you imagined it visually, it was as if the object were painting invisible circles of water around itself, delicate rings that glowed faintly before vanishing into the void. The data from Hubble's final capture showed the same thing. The light reflected off the coma wasn't constant. It shimmered, shifting between hues of green, blue, and white. These colors weren't artistic exaggerations. They represented real differences in how water vapor and carbon compounds refracted light. To the eye, it would have been faint, but to the instruments, it was music. When the final data dump arrived, NASA and ESA scientists sat together in a joint review call. Some were in labs, others at home under dim lights, coffee cups beside them. They watched the graphs scroll by in quiet fascination. It wasn't the kind of discovery that demanded excitement or noise. It was something to be felt in silence. A researcher from the Hubble team said softly, "It's like it's saying goodbye in rhythm." Nobody disagreed, because by then 3I Atlas was on its way out. It had passed the point of maximum brightness, and its trajectory confirmed that it would soon slip back into the vast interstellar dark, farther and farther until its faint water trails disappeared completely. But it left something behind, not in physical form, but in memory. It reminded everyone why they had looked up in the first place. It reminded them that science isn't only about data or theories, it's about wonder. The quiet, patient kind that makes you stay awake under a dark sky just to see a flicker of light that shouldn't be there. And so, even as 3I Atlas drifted away, its faint, rhythmic pulses continued to echo in the minds of those who had studied it, like a metronome of the cosmos, reminding them that somewhere out there, across the endless sea of stars, something still beats in time with us. Far beyond Mars now, 3I Atlas had grown dim enough that even Hubble could barely pick it out from the background stars. Yet, for astronomers across NASA and the European Space Agency, that faint signal was more than enough. The smallest trace of reflected light still carried the fingerprints of the comet's inner chemistry, the secret code of what it was made of, how it moved, and what story it might yet tell. The public thought the story was ending. The cameras had turned elsewhere, to Jupiter's storms, to James Webb's dazzling nebulae. But inside the quiet corridors of space science, nobody had really let go, because there was something still happening. The deeper the agencies looked, the stranger the data became. ESA's Solar System and Exoplanet team released a quiet update, the kind of brief that most people would never notice unless they went looking for it. Continuing analysis of 3I Atlas water emission spectra indicates unexpected persistence of vapor lines despite predicted freeze-out at this heliocentric distance. In simpler words, the comet was still producing water, even though it was now far too cold for that to happen. That shouldn't be possible. Once a comet moves past the warmth of the inner system, sunlight weakens. The ice that once turned to vapor solidifies again. The coma fades, the tail vanishes, and what's left is only silence, a frozen body drifting through space until another star's light wakes it again. But 3I Atlas was still breathing, faintly, persistently. At NASA's Goddard Space Flight Center, a small group of analysts began re-examining the thermal models. They thought maybe the instruments had miscalibrated the infrared readings or that cosmic rays were interfering with the signal. But even after recalibration, the faint signature of water remained. It wasn't strong, Barely a whisper, but it was unmistakably there. When the Hubble archive was checked again, researchers noticed something even more subtle. During the final months of tracking, the light curve, the way the brightness of the object changed over time, had flattened into a near-perfect rhythm. The intervals between the small flashes of reflected sunlight were almost evenly spaced, matching the rotation of the comet. That meant it wasn't just emitting water, it was doing it in cycles like a clock. No natural process quite fits that pattern. Cometary vents should sputter irregularly as internal pressure fluctuates, but 3I Atlas's vents acted almost mechanical. Dr. Ana Velázquez, whose quiet fascination with the object had now turned into a kind of gentle obsession, described it in her field notes. It's behaving like it remembers something, like it's following a rhythm older than itself. She didn't mean it literally, of course, but there was poetry in that thought, and somehow it captured the mood of everyone watching this frozen traveler fade. As more data rolled in from the European Southern Observatory, a new theory began to form. Some suggested that the core of 3I Atlas might not be as solid as most comets. It might contain a porous network, tiny tunnels and cavities where trapped gas could continue leaking for much longer than expected. If those tunnels were insulated by layers of dust, the heat could remain trapped inside for weeks, allowing vapor to keep escaping even in deep space. It was a beautiful explanation. Made sense scientifically, but it also sounded like something alive, because in a way this comet was alive, at least in its own slow, frozen rhythm. Every faint puff of water vapor was like a breath, every shimmer of light like a heartbeat echoing across the void. By now, Hubble had handed over its role to other instruments. The ESA's Gaia Observatory took the baton, mapping the comet's path with exquisite precision as it drifted farther out. Even at this distance, 3I Atlas refused to behave like anything ordinary. Its trajectory, instead of bending neatly under the pull of the sun's gravity, showed a slight deviation, tiny but real. It wasn't enough to suggest engines or artificial control. Rather, it hinted at outgassing from deep within, a subtle self-propulsion that nudged it slightly off course. To the human eye, it would seem still. To the instruments, though, it was a dance, slow, graceful, deliberate. One of the analysts compared the data plots from 3I Atlas with those of 2I Borisov and Oumuamua. All three interstellar objects had displayed quirks. Oumuamua had accelerated strangely. Borisov had broken apart more quickly than expected. And now Atlas, glowing green and breathing water in the cold. It was as if every visitor from the stars arrived with its own personality, its own quiet defiance of our expectations. At the European Space Operations Center in Darmstadt, a group of engineers set up a simulation, a virtual model of the comet's structure, layered with ice, dust, and metallic traces. When they adjusted the internal composition to include small cavities filled with carbon dioxide and hydrogen compounds, the simulation began to match the real emission data. They watched the animation on the large screen, tiny jets of gas bursting outward every few rotations, timed perfectly to the sunlight hitting one particular region. It looked delicate, almost elegant. And yet there was another layer to this. When ESA cross-checked the model against Hubble's ultraviolet spectra, they found faint traces of something else mixed with the water vapor, microscopic metallic particles. Nickel again. The same signature that had appeared months earlier when the comet was still within the orbit of Mars. That raised new questions. How could nickel still be escaping this far out, in the cold? Metal should have condensed long ago. Unless there was something inside the object, a heat source, however weak, that kept the internal structure warm enough to prevent complete freeze-out. Some speculated it could be radioactive decay, remnants of isotopes from its birth in another solar system. Others thought it might simply be friction within the porous tunnels as the gas escaped. But neither idea fully matched the observations. In a late-night meeting, one of the younger analysts proposed something unexpected. What if the nickel isn't evaporating anymore? What if it's being carried out, a attached to the water molecules somehow. At first, that seemed impossible. But then, as they reviewed the infrared data, the ratio of nickel to water did seem oddly constant, like the metal was somehow bonded to the vapor, riding with it into space. It wasn't proof of anything exotic, but it was strange enough to keep everyone thinking. For the public, the updates became fewer and quieter. The world had moved on to other stories, and 3i Atlas faded from headlines. But within the scientific community, it became something like a whisper. A topic brought up in conference hallways, mentioned over coffee breaks, always followed by a thoughtful pause. Because even if the comet wasn't alive, even if it wasn't anything beyond a frozen piece of rock and ice, it had still done something miraculous. It reminded humanity of how little we truly know. Dr. Velasquez said it best during a late interview. Sometimes the universe doesn't give us answers. It just gives us the kind of mysteries that make us gentler. Because when you're humbled by what you don't understand, you start listening more carefully to the sky, to each other, to everything. And maybe that's what 3i Atlas really was, a teacher from another star system, not through messages or signals, but through quiet defiance. A reminder that there is still beauty in the unexplained, and that wonder itself might be the purest kind of truth. Now the comet is nearly gone. Its glow was too faint for most instruments, its pulse too weak to detect. But somewhere beyond the reach of our telescopes, it kept traveling, still spinning, still releasing tiny breaths of vapor that no one would ever see. And perhaps, as it drifted between stars, it carried with it traces of our curiosity, a reflection of all the eyes that had once turned upward to find it. The data logs for 3i Atlas were growing thinner by the week. By now, only the most sensitive observatories could still detect it, and even then, just as a flicker of motion among thousands of stars. Most missions had moved on, but within the quiet hum of late-night research centers, from Pasadena to Paris, some scientists were still watching. They weren't looking for big revelations anymore. They were looking for something quieter. Patterns, rhythms, maybe even a message hidden in the persistence of its behavior. At NASA's Jet Propulsion Laboratory, a senior astrophysicist named Dr. Warren Doyle had been tracking the long-term thermal decay of the comet. Every night he ran new simulations, updating Hubble's final readings with fresh data from ground-based telescopes. For months, he found the same results. The comet should have cooled completely by now. The surface temperature, based on distance from the Sun, was predicted to be close to absolute stillness. No more sublimation, no more gas escape. Yet, something continued to produce faint emissions of water vapor. He'd once described the pattern as a heartbeat, a repeating pulse that didn't quite fit with any known model of natural cometary activity. And the more data he analyzed, the clearer it became that the timing was far too consistent to be random. Every 36 hours, give or take a few minutes, there was a detectable increase in the waterline intensity. It was faint, so faint that many dismissed it as statistical noise, but the signal returned each cycle without fail. Dr. Doyle wasn't a man drawn to speculation. He'd built a career on being careful, cautious. But as he looked at those repeating curves, the thought crept in again. What if this wasn't just a chemical reaction? What if it was something programmed? He didn't write that down. He just adjusted his glasses, typed another note into the file, and added one more line of data to the long column of water emission intervals. At roughly the same time, the European Space Agency's Operations Center was cross-checking Hubble's archived data with new readings from Gaia and the Very Large Telescope in Chile. The goal was to refine the object's trajectory for as long as possible before it slipped completely into the darkness between stars. The results surprised them. For the past several months, 3i Atlas had been slowing down, but not in the way expected from solar drag or the faint pull of interplanetary dust. Instead, the deceleration appeared to occur at precise intervals that matched the rhythm of its water emissions. Every time the vapor levels peaked, the comet lost a tiny bit of speed. It was as though each pulse of gas acted like a microthruster, nudging it in deliberate increments. Again, the natural explanation would be sublimation, gas venting unevenly across the surface. But the pattern didn't match random outgassing. It matched my intention. Dr. Doyle received the European report one morning just before sunrise. He read through the numbers in silence, his coffee long gone cold. The rhythmic emissions, the synchronized deceleration. Together they told a quiet, strange story. He leaned back in his chair, looking at the old Hubble images of the green glowing coma. "You're still talking to us," he murmured. Outside his office window, dawn was beginning to pale the horizon. He could almost imagine the comet out there, far past the orbit of Jupiter now, trailing its delicate stream of vapor like a message fading into space. Meanwhile, across the Atlantic, ESA's astrophysics team prepared a quiet release, a technical summary, written in the cool language of science. Spectral analysis of 3I Atlas continues to indicate intermittent water emissions beyond predicted thermal stability limits. Data consistency across instruments confirms the anomaly as genuine rather than statistical artifact. In simpler words, it's real. The water is still there. We don't know why. When the press asked for comment, ESA's spokesperson smiled gently and said, "Space continues to surprise us." That was all. But inside the agency, the tone was more electric. Scientists were sending messages to one another late at night. Short, excited notes filled with equations, half-finished theories, and sketches of models that might explain the impossible. They didn't call it an alien signal or a machine. They didn't even use words like intelligence. But the undercurrent was there, quiet and thrilling. What if we're watching something that knows how to keep itself alive? It wasn't about science fiction. It was about the beauty of the unknown. NASA and ESA scheduled a joint symposium, small, private, mostly remote, to share their latest findings on interstellar visitors. The session on 3I Atlas opened with a simple statement. Unexpected persistence of water emission lines may suggest unique compositional or structural mechanisms not yet understood. Then came the data plots, the faint peaks repeating at 36-hour intervals. The mathematicians in the audience noticed immediately how regular the intervals were. The odds of such symmetry occurring naturally were extremely low but not impossible, so they argued. Some said the comet's internal structure could be layered in such a way that heat was trapped, escaping periodically through vents. Others pointed out that the data implied too much precision for random thermal cycles. The debate wasn't heated. It was thoughtful, calm, like a group of poets trying to understand the rhythm of a mysterious song. Dr. Doyle spoke near the end of the session. He didn't claim anything definitive. He simply said, "We may be seeing a kind of physics we don't fully understand yet. A slow process, subtle, deliberate, but entirely natural. Or perhaps the line between natural and deliberate isn't as clear as we once thought." The room was silent for a moment. Then someone murmured, "That's beautiful." Afterward, as participants signed off one by one, a quiet stillness remained. The comet had united them again, not through proof or discovery, but through wonder. Weeks later, ESA released a visualization built from the combined data. It showed 3I Atlas spinning slowly, releasing soft bursts of vapor like sighs in the cold. The color-coded mapping displayed nickel traces entwined with the water jets, glimmering faintly in ultraviolet light. The video went mostly unnoticed by the public, but those who watched it felt something hard to name, a quiet sadness mixed with awe. Somewhere, a lone traveler from another star was still shimmering against the dark, whispering a pattern only the patient could hear. In his journal that night, Dr. Doyle wrote, "We used to think that space was empty, but what if it's filled with memories, old ones carried by ice and dust? Maybe these travelers are reminders that the universe is still breathing in ways we haven't learned to listen for." That line would later be quoted in an astronomy newsletter under the heading "The Quiet Mystery of 3I Atlas." No one knew it yet, But that phrase, quiet mystery, would define how humanity remembered the comet. It wasn't famous like Oumuamua, nor as spectacular as Borisov, but it lingered softly in the imagination of anyone who took the time to notice. And perhaps that was the point. Sometimes the universe doesn't shout, it whispers. And in that whisper, we find not fear, but belonging. By the time 3I Atlas crossed the threshold of Saturn's orbit, it had become little more than a faint shimmer on the instruments, a vanishing echo of light that seemed to hover on the edge of reality. To most of the world, it no longer existed, but to a small group of watchers, astronomers, engineers, students who had fallen in love with the idea of an interstellar visitor, it still felt alive, still worth listening to, because even in its fading silence, the comet had not stopped behaving strangely. The Hubble archive, long since closed for new observations of Atlas, had left behind an enormous dataset. Layers upon layers of readings, spectral bands, reflectivity maps, and ultraviolet light curves, each one holding a fragment of the comet's personality. ESA had taken those fragments and begun feeding them into a new kind of analysis model, a cross-correlation algorithm designed to detect weak, repeating signals that might be lost in background noise. It was an experiment meant for exoplanets, but one engineer suggested applying it to Atlas just for fun. What they found was subtle but beautiful. Across months of faint ultraviolet data, the emissions weren't just rhythmic. They formed a slow modulation, almost like a wave that rose and fell over weeks. The team didn't claim it was communication. No one dared to. But the pattern's symmetry was enough to make even the most cautious minds pause. One researcher wrote in her report, "The data set suggests a periodic emission pattern consistent with cyclic venting behavior, though the regularity exceeds typical stochastic limits for outgassing events. If random, it is the most elegantly random process we've ever recorded." In other words, it was either chance or something that mimicked purpose with startling grace. Meanwhile, NASA's Jet Propulsion Laboratory had begun quietly revisiting Oumuamua's old data, comparing it to what Atlas had shown. And there too they noticed echoes, the same inexplicable steadiness, the same deviation from expected gravitational paths. It was as though all three interstellar visitors, Oumuamua, Borisov, and Atlas, had each carried a piece of a larger puzzle. One scientist described it like this: "If these are letters from the stars, then Atlas is the one still glowing faintly at the end of the sentence." And so the quiet collaboration between NASA and ESA deepened, not through press releases or bold discoveries, but through long, slow nights of shared curiosity. They began comparing water spectra, not only across comets, but across known molecular clouds in nearby star systems. The faint oxygen-hydrogen signatures that made Atlas so distinctive seemed to align with a region near the constellation Sagittarius, a place already rich with hydrogen emissions, the same region where, decades earlier, the mysterious wow, a signal had been heard. That coincidence wasn't lost on anyone. But rather than jump to conclusions, the scientists treated it as poetry. It was as though the same patch of sky kept whispering small riddles to anyone who cared to listen. Dr. Ana Velasquez, whose gentle fascination with 3I, Atlas had never really faded, found herself revisiting her old notes. She'd written once that the comet behaves as though it remembers something. Now, looking at the long-term emission graphs, she realized that phrase might not have been so far off. When she compared the emission intervals to the object's rotational period, she saw something quietly astonishing. Every cycle of increased water release corresponded perfectly to the same region of the comet's rotation. It wasn't venting randomly across its surface, it was venting from the same spot each time, like a pulse repeating from a single scar. That meant heat was being stored deep within, only escaping through one enduring vent. But what kept that spot warm when the rest of the comet should have frozen solid long ago? ESA's laboratory in Nordwijk ran simulations, testing how a small radioactive element, something like aluminum-26, common in the early days of stellar formation, could continue to produce heat millions of years later if trapped beneath insulating layers of dust and carbon. The math almost worked, almost. But the heat output was still too low to explain the persistent vapor. NASA's modeling team proposed another idea: friction. As the comet spun, its internal dust grains could be rubbing, compressing, and releasing microenergies, tiny, nearly undetectable heat sources that together could sustain localized melting. It was possible, barely. But none of it explained the rhythm, the perfect 36-hour pulse that kept repeating, even as Atlas drifted farther and farther from the sun. At a small science outreach event in Washington, Dr. Doyle was asked about it by a student. "Do you think something could be controlling it?" she asked, her eyes wide with honest wonder. He smiled softly. "If there is," he said, "then it's not the kind of control we understand. Maybe it's just physics, on a scale or in a form we haven't discovered yet. Nature doesn't have to be random to be beautiful." The student nodded thoughtfully, and for a moment the whole auditorium was quiet. Meanwhile, on the other side of the world, in the high deserts of Chile, a small team of astrophotographers were doing something that had started this entire journey years ago, pointing their cameras toward a patch of sky that no one else was watching anymore. The desert was cold and silent. The Milky Way stretched across the heavens like a silver river. They couldn't see Atlas directly anymore, but they could see its path, an invisible trail marked by data, by prediction, by faith. And when they processed the images later that night, they noticed something faint but striking. A soft green reflection, diffused, almost ghostly, in the region where the comet was predicted to be. It was far too dim to be sure, but the sight brought tears to one of them. "Maybe it's still glowing," she whispered. Back in Europe, ESA's final report on 3I Atlas was quietly published in the Astrophysical Journal. It contained no dramatic claims, no sensational conclusions, just a single modest statement that would stay with readers for years. The continued detection of water emissions at great heliocentric distances suggests that 3I Atlas retains an internal mechanism of heat preservation or release not yet understood. Further observation of future interstellar visitors may help us learn whether this behavior is unique or universal. That single sentence became something like a lullaby among those who loved the stars. Because it said, without saying it, that mystery is not failure, it's invitation. And that's what 3I Atlas had been all along. An invitation to wonder, to listen more closely, to imagine that even a frozen fragment from another star could carry stories older than our own. For those who had followed it from the beginning, its faint, rhythmic glow had become part of their inner night sky. A quiet friend, drifting away, still whispering water into the void. The comet was now beyond Saturn, soon to pass Neptune's reach. After that it would be gone, back into the dark sea of interstellar space, maybe never to return. But the data it left behind, the graphs, the spectra, the faint lines of water and nickel, would remain in the archives of Earth, waiting for others to find them. And maybe one day, when another strange green traveler appears in our sky, we'll remember the first one that taught us how to listen. Because sometimes the universe doesn't reveal itself with explosions or noise. Sometimes it teaches us through persistence, through quiet regularity, through one steady rhythm of water in the dark. That's what 3I Atlas left behind. Not an answer, but a song. And if you listen carefully, even now you might still hear it drifting through the silence, a soft hum of science and starlight echoing between worlds. Long after 3I Atlas faded from the range of even the most sensitive telescopes, its name continued to linger in the halls of observatories and classrooms like a faint afterglow. Scientists still debated what exactly had happened. Not in the loud, headline-chasing way the news once covered it, but in that gentle, persistent hum that real science often becomes after the cameras go away. It was no longer about breaking news. It was about quiet understanding. The European Space Agency had closed their official mission report, Yet several teams continued studying the data unofficially. Some did it out of habit, others out of love. They didn't expect to find proof of alien intelligence, nor did they chase conspiracies. What drove them was something more human, that irresistible tug of curiosity that keeps astronomers awake beneath the soft blue glow of monitor light, chasing meaning in noise. And in the months that followed, something odd began to emerge again. ESA's infrared analysis lab in Spain found a recurring trace of water vapor emissions that didn't match the comet's known trajectory. It wasn't from Atlas itself, that was long gone, but from a faint dust trail that had broken away from it during its journey past the sun. This fragment, no larger than a mountain, seemed to be releasing bursts of water vapor, even though it should have been frozen solid. It pulsed faintly every few days like a remnant heartbeat. The researchers double-checked everything: calibration, equipment, data timestamps. But the signature was there, persistent and undeniable. They nicknamed the fragment Echo. To the public it was a non-story, but to those who had followed Atlas since the beginning, it was poetic. As though the comet had left behind a whisper of itself. Dr. Ana Velázquez read about it late one evening in her apartment, a cup of coffee long gone cold beside her. The glow from her laptop screen painted faint shadows across her face. She read the numbers twice, then 3 times, before closing her eyes and imagining it. A tiny shard of interstellar ice still breathing, slowly, rhythmically, out in the darkness. She smiled to herself. "You're still talking," she whispered. Across the ocean, at NASA's Goddard Space Flight Center, another analysis was underway. This one wasn't about water, it was about light. They had been re-examining the last ultraviolet readings taken by the Hubble Space Telescope before Atlas moved out of view. A graduate researcher noticed something overlooked in the noise: faint spectral variations that repeated every time the comet completed a rotation. It was subtle, so subtle that most algorithms dismissed it as instrument interference. But when the data was cleaned and reprocessed, the pattern remained. It was as if certain wavelengths brightened and dimmed on schedule, synchronized perfectly with the comet's spin. At first, the team assumed it was sunlight reflecting off surface ice. That would make sense until they realized the intensity changes were too consistent, too regular. Reflection should fluctuate as the surface sublimates or erodes. But here, the pulse had barely changed over weeks. A rhythm without decay. One of the astrophysicists quietly joked, "It's like it's keeping time." Everyone chuckled, but no one could fully dismiss the thought. Meanwhile, the James Webb Space Telescope, still in its own silent orbit, far from Earth, was busy with other missions. Yet, tucked in a forgotten folder, were readings taken when Webb's instruments had briefly observed Atlas before it vanished from range. Those readings contained something no one had yet interpreted: a narrow emission band near the infrared line associated with water transitions, but slightly off. When recalculated using Webb's higher sensitivity, it showed a tiny frequency shift, not random noise, not a calibration error, but a deviation consistent with molecular vibration under unusually stable temperature conditions. Stable temperature in a comet drifting millions of miles from the sun. That meant some internal process, chemical, perhaps mechanical, was maintaining balance inside. It wasn't a roaring engine, not a glowing core, nothing cinematic, just a steady hum of molecular motion, as if the comet had learned to breathe in deep space. By late spring, NASA and ESA shared quiet notes again. No press release, no excitement, just data, plain and careful. The correspondence between them was respectful, thoughtful, almost intimate. One researcher wrote, "It's humbling. The object doesn't seem alive, but it doesn't seem dead either. Maybe we've been too quick to draw that line." That phrase lingered. Too quick to draw that line. Because what if there were gradients of life? Not life as we know it, but patterns of persistence. Structures that could store warmth, regulate their chemistry, even repair microscopic damage across millennia. Maybe not intelligence, but something self-sustaining, something that resists chaos just enough to continue. And perhaps 3I Atlas was one of those. Not a ship, not a being, but a fragment of matter from a far-off system, carrying within it the quiet rules of its own endurance. Dr. Doyle, now semi-retired but still teaching part-time, gave a talk about this idea at a university planetarium. The audience sat beneath a dome painted with stars. The air was dim, calm, the kind of silence that invites thought. He said softly, "You know, we often imagine the universe as either alive or lifeless. But maybe it's both. Maybe it's alive in ways we haven't learned to recognize yet. When I look at what Atlas showed us, the water, the rhythm, the improbable heat, I think it's trying to remind us that not everything fits into our boxes." A student raised her hand and asked, "So you think it's conscious?" He smiled. "No, but I think it's coherent." And that might be the first step toward something like consciousness. The universe loves patterns. Maybe someday those patterns will learn to look back. Outside, the night sky shimmered faintly with city haze, but the stars above the dome glowed clear. For a few moments, everyone sat still, each lost in the same thought, that maybe the cosmos was not empty, not silent, but gently breathing just beyond the edge of hearing. And still, from time to time, telescopes in orbit around Earth caught flickers of something faint in the direction where Atlas had gone. Nothing to analyze, nothing to publish, just soft hints of water vapor, a molecule or two escaping into infinity. The scientists called it noise, but some of them in quiet moments chose to believe it was the comet saying goodbye. Because maybe when you send something across the stars, even a frozen traveler of rock and ice, it carries a piece of its origin with it, a rhythm, a pattern, a reminder. And somewhere, out there in the dark, it's still unfolding, one molecule at a time, still whispering that simple message. I was here. I came this far. The universe is vast, yes, but not indifferent. It listens. It records. It holds memory in the faintest shimmer of a water molecule, in the glow of a comet that refuses to behave. And if you listen closely enough, not with telescopes but with patience, you might still hear the echo of Atlas's journey, a faint song of persistence moving ever outward into the sea of stars. When the scientific papers faded from the news cycle, when the conferences moved on to the next discovery, something unusual started to happen behind the scenes. A few scientists quietly, carefully, couldn't let go of 3I Atlas, not because they thought it was alien or magical, but because it had unsettled them in the best possible way. It had forced them to rethink what they thought they knew about water, space, and motion itself. Among them was Dr. Seelig, a data specialist at the European Space Agency, who had spent months studying every archived reading Hubble and the ESA probes had collected from Atlas. He wasn't looking for fame or theories, he was simply fascinated by the shape of the data. There was an elegance to it, a pulse-like pattern that shouldn't have existed in a dead, frozen object. Every few hours, something about the signal changed, subtle, precise, rhythmic. He would sit late in the lab after everyone else had gone home, the only light coming from his monitor and the faint glow of the Earth beyond the window. He'd listen to the soft hum of the cooling fans and imagine the data as sound, pulses in the dark, like a faraway heartbeat. Sometimes he'd play the readings as low-frequency tones through his speakers. The numbers translated into a soft wave of hums, slow and even. It was like listening to breathing. It wasn't proof of anything, but it made him wonder. One evening, his colleague, Dr. Amira Lau, stopped by his desk. "Still listening to your ghost comet?" she teased. He smiled. "It's not a ghost. It's too consistent." She leaned on the doorway. "Maybe you're just hearing yourself in it. You know how our brains love patterns?" He nodded. "Maybe, or maybe we're just not listening long enough." That line hung in the air, and she didn't argue. She just sat beside him, eyes on the soft, rippling data graph that pulsed in perfect rhythm. The next morning, they sent the data set to a research group in Chile with a new high-altitude spectrometer. The team confirmed the same micro-fluctuations, tiny but measurable, like waves of energy released at regular intervals. They couldn't explain it. It wasn't radiation, it wasn't reflection, and it wasn't instrument noise. It was something happening inside the remains of the comet. Over time, that tiny anomaly began to spark questions that went beyond astronomy. Could interstellar objects carry some kind of self-regulating mechanism? Not a biological one, but chemical or mechanical, a process that stabilizes temperature, disperses pressure, or maintains internal structure. It would make sense if you wanted an object to survive a journey of billions of years. ESA quietly published a paper written in the careful, cautious tone scientists use when they're admitting curiosity but avoiding speculation. The title was simple: Recurrent Energy Modulation in Interstellar Object 3I Atlas. Inside, there were no bold claims, just quiet marvel. Phrases like unexplained rhythmic consistency and potentially indicative of internal equilibrium mechanisms. And between those words, you could feel it, the wonder. NASA's Hubble team later confirmed faint secondary readings that seemed to align with the rhythm. They too avoided conclusions, but in private communications, one astrophysicist wrote, "If we are seeing real modulation, it means Atlas may not have been a passive matter. It may have been active in ways we don't yet understand." That sentence leaked into online discussions, misquoted and exaggerated. Blogs turned it into "NASA admits comet is alive," and that made headlines for a few days before vanishing under more dramatic news. But in the small, quiet corners of the scientific community, the idea persisted. Not life, not consciousness, but something in between. Something that wasn't inert. Meanwhile, far from the scientists and their instruments, people continued to look up at the night sky, trying to spot a comet that was no longer there. Amateur astronomers searched not for discovery, but for a feeling, for that strange sense of connection they'd felt when Atlas had crossed our skies. In a small observatory in Namibia, the same place those bright green images had once been captured, a volunteer named Johan set up his telescope again. He knew Atlas was gone, but sometimes, on perfectly clear nights, he would look toward the same patch of sky anyway. He said it made him feel grounded. "I know it's not there," he told a visiting journalist once, "but space remembers. The trail's still out there, maybe too faint for us to see. But light never really disappears, it just fades." And then he said something the journalist never forgot. Maybe Atlas didn't leave. Maybe it just changed its way of being seen. Months later, the European Space Agency released one final observation summary. It was a calm, factual document filled with charts, graphs, and images. But at the end of the report, in a brief paragraph near the acknowledgements, there was a sentence that read, "The recurring release of water vapor from 3I Atlas remains an unresolved phenomenon. It is the first known interstellar object to exhibit such behavior under these thermal conditions." That was it. No speculation, no poetry. Just a statement of fact that to anyone reading carefully said everything. And maybe that was enough, because sometimes the greatest mysteries aren't the ones that shout for attention. They're the ones that linger quietly, whispering through data, humbling those who try to measure them. Dr. Velasquez read the final report alone one night. She smiled softly and closed her laptop. Her window looked out onto a city sky, washed out by light pollution, but somewhere beyond that haze, beyond all the glow of human noise, she knew Atlas's trail was still drifting. She thought about the first detection, the green light, the unexpected pulse of water, the rhythmic modulation, and how every piece had formed a kind of cosmic melody. Maybe the universe wasn't just a collection of cold equations. Maybe it was music, faint but steady if you knew how to listen. She leaned back and whispered to herself, "You kept your secret well, didn't you?" Then she added after a pause, "Or maybe it wasn't a secret. Maybe it was just your nature. Outside, the night wind brushed against her window. Somewhere, above the reach of sound or sight, a forgotten fragment of 3I Atlas still glided between stars, trailing a faint shimmer of water that caught the light of distant sun. If you could follow it, if you could drift alongside it, you might not find answers. But you would feel something else, something older than explanation, quieter than proof. You'd feel wonder. And that was perhaps the truest kind of discovery humanity could ever hope for. By the time the year came to a close, most of the world had moved on from the comet that once filled so many screens and headlines. People's attention drifted to new stories, new discoveries, new mysteries. But for a handful of astronomers, 3I Atlas was still very much alive in their minds. Its story was unfinished, its patterns still echoing in the background noise of the universe. At a quiet research outpost in Chile, perched high in the Atacama Desert, a small team of scientists continued to scan the sky where Atlas had once glided through. The air there was thin and clear, untouched by clouds or city light. Every night, they would point their instruments at that empty patch of darkness. Not because they expected to see the comet again, but because something in the data kept calling them back. It started as a faint distortion like static in a radio signal. Every so often, when the instruments swept past the region where Atlas should have been, the sensors caught a pulse, small, consistent, repeating every few hours. At first, they thought it was interference from satellites or cosmic rays. But when they checked the timestamps, they realized something strange. The pulses were synchronized with the exact rotational period that Hubble had measured months earlier, the same rhythm Atlas once had when it emitted those unexpected bursts of water vapor. The comet was gone, and yet, somehow, its pattern remained. Dr. Emilio Navarro, the lead researcher on the project, sat quietly in front of his monitor one night, the data scrolling past like slow breathing. He rested his chin on his hand, eyes half closed, as if listening to something far away. The pulse came again, soft and precise. He whispered, "You're still out there, aren't you?" One of his younger assistants leaned over his shoulder. It could be reflected in interference, the same signal bouncing between clouds of dust. "Maybe," Emilio said, still watching the rhythm appear and fade. But even echoes have to come from somewhere. The signal wasn't strong enough to publish. It wasn't even strong enough to confirm. But in the world of astronomy, mystery was a kind of fuel. And for the first time in years, Navarro felt the same childlike awe that had drawn him to space in the first place. He leaned back, closed his eyes, and imagined the comet, or what was left of it, still gliding silently beyond the reach of sunlight, its fragments coated in frost, its trail glowing faintly like a silver thread. The pulse, he thought, might just be the universe's way of saying that nothing ever truly vanishes. Meanwhile, across the ocean at NASA's Jet Propulsion Laboratory, an intern named Lila uncovered something similar in the archived telemetry. She had been tasked with reprocessing old Hubble data, cleaning noise, and organizing spectral logs for future projects. It was routine, quiet work, the kind of work most people overlooked. But while comparing exposure sequences, she noticed a recurring spike in the ultraviolet readings from one of Hubble's secondary sensors. The spike matched precisely the timing of the Chilean observations, hours apart, but still locked to the same rhythm. Lila didn't know about Navarro's signal. She didn't know that anyone else was still watching. But she felt that same quiet excitement, that same whisper in her thoughts. This means something. She brought it to her supervisor, a weary scientist named Dr. Claire Watanabe, who had spent years studying comets and interstellar dust. Claire glanced over the screen, sighed, and said softly, "It's probably solar interference. Hubble's sensors are sensitive enough to pick up changes in the solar flux." But later that night, when everyone else had gone home, Claire opened the file again. The pulse was there, steady, deliberate, patient. She stared at it, and for a moment, The hum of the lab's fluorescent lights seemed to fade into silence. "What if," she murmured, "this isn't interference? What if it's a memory?" She didn't mean it literally. She didn't think comets remembered things like humans did. But maybe, just maybe, the universe itself carried memory. Patterns that echoed through dust and ice, repeating endlessly in ways we hadn't learned to interpret yet. When Claire compared the rhythm to data from other interstellar objects, she found nothing similar. Oumuamua had its erratic tumbling. Borisov had its violent bursts of gas. But Atlas had harmony. Days later, she reached out to the team in Chile. The time difference made it difficult, but eventually, Navarro and Watanabe connected over a low-latency call. The two scientists, separated by thousands of miles, stared at the same flickering graphs. They didn't say much at first, just watched, just listened. Finally, Navarro said, "It's almost like it's repeating itself, like a signal encoded in vapor." Watanabe nodded. "Or like a clock that never stopped ticking." They both smiled faintly. Scientists were supposed to be skeptics, trained not to believe in coincidences or cosmic poetry, but they were also human. And humans, no matter how rational, have always been drawn to rhythm, to pattern, to wonder. Together, they began comparing data, lining up timestamps, eliminating sources of interference. What they found wasn't proof of anything extraordinary. It was simply consistent. A soft pulse of energy that continued long after Atlas had vanished. When they presented their findings to ESA's research board, the reaction was polite but cautious. Residual radiation, one expert suggested, possibly dust interaction. Another said, without correlation from multiple sources, it's inconclusive. But Navarro and Watanabe didn't mind. They weren't searching for recognition. What they found was something deeper, a sense of connection to the cosmos that didn't need validation. That night, after the meeting ended, Claire stood outside the observatory dome, watching the stars. The air was cold and still. Somewhere out there, a speck of rock and ice from another star system was still drifting, carrying the rhythm of its creation. She whispered, "You made us listen differently." And she knew that was the truth. Atlas had changed the way they looked at the universe. It had turned a telescope into an ear. Maybe that was its real purpose all along. For centuries, humans had looked up at the night sky asking, "What's out there?" But maybe, just maybe, the universe was quietly asking back, "Are you listening?" Claire smiled, watching her breath form small clouds in the cold air. "We're listening now," she said, and somewhere beyond the reach of radio waves and starlight, perhaps the last fragments of 3I Atlas drifted through the interstellar dark, still pulsing, still releasing water vapor molecule by molecule, not as a signal, not as proof, but as a quiet reminder that even across impossible distances, connection is possible, that even in silence, something always speaks, and that maybe what we call discovery is really just recognition of a voice that was there all along. The night sky never truly goes dark, it only grows quieter. That's what Dr. Claire Watanabe used to tell her students in the soft after hours of the lab, when the computers hummed like distant insects and the coffee had gone cold hours ago. After Atlas, she said it more often, not because it sounded poetic, but because it felt true. Months passed, and yet Atlas lingered. Not as an image, not as a visible streak through the stars, but as a question that wouldn't let go. The data, the rhythm, the pulse, it became a kind of haunting comfort. Something that reminded them that science wasn't about certainties. It was about listening to what didn't make sense and allowing wonder to take shape inside that silence. By the time the European Space Agency finished cataloging every last bit of data from Hubble and James Webb, the official conclusion was simple: unexplained emissions. Those two words, written in precise scientific language, carried the weight of everything humanity still didn't understand. Unexplained emissions. Dr. Navarro liked to say it sounded more like a poem than a result, and perhaps it was. When he met Claire in person for the first time, at a quiet symposium in Switzerland, far from the crowded halls of the bigger conferences. They didn't talk much about data. They talked about sound, about rhythm, about how something as simple as repeating light curves could feel like breathing. Over coffee, Claire said, "It's strange. We spend our lives measuring things, but the moment we find something we can't measure, that's when we feel closest to the truth." Navarro nodded. "Maybe the universe leaves gaps on purpose, so we don't forget how to wonder." Later that night, he found himself standing outside his hotel, staring up at the cold European sky. Clouds moved slowly across the moon, and beyond them, somewhere too far to see, Atlas drifted on. He imagined it as it once was. That faint green shimmer, the mysterious water vapor, the slow, deliberate rhythm of its rotations. He thought of how it came from another star system, older than our sun, carrying the chemical fingerprints of a place humans would never touch. And yet, it had passed through our solar system as if stopping to say hello, a visitor from the deep, carrying whispers from another time. Maybe the water emissions were nothing more than chemistry, frozen molecules heated, vaporized, and released in an elegant rhythm dictated by physics. But then maybe they were something more. Maybe they were a kind of language the cosmos used, one we hadn't yet learned to read. Scientists love precision, but they also love beauty, and in the faint glimmer of a dying comet, there was both. A few months later, a small group of amateur astronomers in Argentina caught a faint streak of light near the coordinates where Atlas would have been traveling. It wasn't confirmed, and no major observatory picked it up. But one of the images, grainy and uncertain, showed a diffuse blue-green haze, a color too faint to classify, yet strangely familiar. They didn't publish it. They didn't need to. They knew what they'd seen. News didn't travel fast about it, but the scientists who had followed Atlas from the beginning eventually heard. Claire received the image in her inbox one morning. She stared at it for a long time, not smiling, not frowning, just breathing. "It's still talking," she said softly, and she realized that in a way, every discovery humbles us not because it gives us answers, but because it reminds us how small we are in the vast, breathing universe. For thousands of years, humans had looked up at comets and seen omens, messages from gods or signs of doom. But maybe, just maybe, they were messages after all, not of warning, but of recognition. A quiet reminder that we're part of something older, grander, and impossibly wide. Water, that simple molecule, had been the messenger this time. The same water that fills our oceans, that drips from our rain, that forms in the tail of a comet light years from home. The same water that carried the fingerprints of distant stars now flows through us. When she lectured again months later, Claire didn't open with equations or graphs. She dimmed the lights, projected the faint green image of Atlas on the screen, and said, "Everything that moves through the universe leaves a trace. Even this, especially this." She told her students about the unexpected emissions, about the rhythm that refused to die, about the data that still whispered through satellites orbiting Earth. And then she paused, looking around the room. "Maybe," she said softly, "the universe is trying to remind us that we are part of its memory." When Atlas released its water, it wasn't giving us a mystery. It was giving us a mirror. Outside the lecture hall, the evening sky stretched wide and still. The stars were faint, dimmed by the city's glow. But if you looked hard enough, you could still imagine that streak on the traveler from beyond, sliding quietly across the darkness, carrying its unseen cargo of frozen light. No one will ever know for sure what 3i Atlas truly was. But it didn't need to be alive to make us feel more alive. It didn't need to be conscious to make us aware of consciousness. It just needed to exist, to cross paths with our tiny corner of the cosmos, leaving behind a trail of vapor and questions that would outlive its passing. And in the stillness of the night, as telescopes turned away and computers went dark, the universe remained as it always had been, immense, silent, and filled with quiet, patient light. Somewhere beyond the solar wind, Atlas drifted on. Perhaps in 1,000,000 years, it would pass another star system, and another civilization would notice its faint emissions and ask the same questions we did. Perhaps they too would gather around their version of telescopes, whispering to one another in wonder. Perhaps they would call it by a new name. And maybe, just maybe, they would understand the same thing we finally did in that mystery is not the absence of knowledge, it's the heartbeat of discovery. And as long as something like Atlas can pass through the universe and make us look up, then wonder, it seems, is alive and well. The universe exhales, the stars listen. Long after the last official dataset was closed and stored in archives, long after the public had stopped asking about the green comet from another star, a quiet movement began in the background of science. Not an organization, not a mission, but a habit of thought. You could see it in the way scientists wrote their papers, a little more humility between the lines. You could hear it in lectures when a teacher paused longer before explaining something as simple. The universe had once again reminded humanity that there is no such thing as simple when you are made of stardust trying to understand yourself. For Dr. Claire Watanabe, 3I Atlas had become part of her internal rhythm. Not just an object of study, but a way of seeing. She began starting her lectures with a soft slide of the comet, suspended in blackness, its coma faintly glowing. The audience always fell quiet when it appeared, as if the air itself remembered something. Water, she would begin gently, is the universe's handwriting. It shows up wherever life might be possible, but sometimes it shows up where life should not be at all. Her students listened differently after that. They didn't fidget, they didn't whisper. They watched, and Claire would tell them how Hubble had captured that strange shimmer of vapor, how ESA's instruments had confirmed emissions where there should have been none, how the universe had whispered through data. She didn't present it as a mystery to be solved. She presented it as a story to be felt. It may not have been life, she would say softly, but maybe it was a reminder of what life does. It defies stillness. It changes. It releases energy. It keeps time. And that phrase, keeps time, stays with them. Years later, one of her students, now an astrophysicist herself, would write in a published essay, 3I Atlas taught us to listen to the patterns we can't yet explain. Maybe discovery isn't about breaking the unknown apart. Maybe it's about sitting with it long enough for it to speak back. That essay spread quietly through scientific circles. It wasn't sensational. It didn't claim alien intelligence or hidden technology. It was human, thoughtful, and deeply calm, like Atlas itself. Even now, telescopes across the world occasionally pick up soft, faint glimmers in the direction of where Atlas once was. They don't register as new comets. They don't even trigger automatic alerts. Just quiet blips of reflected light and water vapor, molecules carried on the breath of solar wind. To the untrained eye, they mean nothing. But to the ones who had listened to Atlas, who had measured its rhythm and learned its patience, those blips were a kind of comfort. Dr. Navarro, retired but never fully away from science, had a small telescope installed on the roof of his home by the coast. It wasn't a professional instrument, just enough to capture the faint traces of light above the horizon. He would spend hours watching, not to find anything, but to remember how it felt to wonder. He said once, "It's funny. We call these things objects. But I think Atlas was a mirror. It had made us see our reflection, all our assumptions, our limits, our questions. And when the wind shifted across the sea and the stars shimmered faintly through the mist, he liked to imagine that somewhere far away, Atlas was still moving through the dark, carrying its strange memory of another sun, another home, another rhythm. That idea, that something could travel across billions of miles just to remind us we're part of something shared, stayed with him. It stayed with Claire. It stayed with every person who had ever looked up that year and seen the faint green shimmer of a comet not from here. Some nights Claire still dreamt of it, not as numbers, not as graphs, but as a feeling A long, slow drift through darkness, surrounded by silence so deep it sounded like music. In that dream, she would sometimes hear the sound she once imagined from Atlas's pulse, soft and steady, like a heartbeat too large to belong to any creature, and yet familiar. When she woke, she'd write a few words in her notebook. "It's not the comet we study, it's what it leaves behind inside us." And then she'd smile because that was the closest thing to truth she had ever found. By the time the next interstellar visitor appeared decades later, humanity was different. They didn't greet it with panic or skepticism. They greeted it with reverence, with the quiet, collected wonder that Atlas had taught them. The telescopes turned, the instruments hummed, the scientists whispered, "Welcome." And for a moment, just a moment, it felt as though the universe had smiled back. Because every discovery begins the same way, with something unexpected, something that breaks the rhythm of what we think we know. 3i Atlas had been that break, a single, irregular note in an otherwise predictable symphony. But in that disruption, it had reminded humanity of the beauty of uncertainty. No one could prove what Atlas was trying to say. But then again, maybe it was never about saying anything at all. Maybe it was about showing us how to listen. The stars didn't change because of Atlas. The comets didn't change their paths. But the people watching, they did. And that's how the universe speaks, not through miracles or messages, but through the small, quiet shifts it leaves in the hearts of those who pay attention. Somewhere, beyond the outer edge of the heliosphere, the fragment of 3i Atlas drifted on, bathed in the faint light of distant suns. Its water molecules glowed for an instant, then faded into vapor, merging with the endless dark. It wasn't gone. It was becoming part of everything, just as we all do in the end. And so the story of 3i Atlas, the traveler, the enigma, the mirror, didn't close with an answer, but with an echo, a soft, patient rhythm that said, in its own wordless way, keep wondering, keep listening, keep looking up. And somewhere, beyond the edge of the known solar wind, that faint whisper seemed to ripple, not as a sound, but as a feeling that moved through space like a heartbeat stretched across eternity. Scientists would later say that there was nothing left of 3i Atlas to study, no debris, no detectable trail, no echo of its passing. Yet deep space instruments continued to pick up faint fluctuations, tiny shifts in light wavelengths and hydrogen emissions that appeared and disappeared without pattern. Most dismissed them as background noise, but a few kept listening. Claire, older now, still returned to her observatory late at night, long after the students had gone home. The air smelled of rain and metal. The hum of machines was familiar, almost alive. She no longer hunted for comets or distant stars. She watched the black between them. Sometimes she'd catch herself whispering, not to anyone, but to the sky itself. "Where did you go?" The question didn't need an answer. It was enough just to ask for it. Across the sea, Dr. Navarro's telescope still turned toward the same coordinates. He wasn't measuring or logging data anymore. He was just watching the stars breathe. And when a faint glimmer pulsed once, and then again, in the same corner of the sky where Atlas had first appeared, he smiled softly. "Still there," he murmured. Or maybe just reminding us. In time, stories of Atlas became more like myths than case studies. New generations of astronomers would learn about it in textbooks, a brief chapter, a passing mention of a green interstellar visitor with inexplicable water emissions. But in the quiet labs and observatories, it was spoken of differently, almost reverently. It was never the data that stayed with people. It was the feeling, that delicate balance between knowing and not knowing, between the measurable and the miraculous. And so Atlas became a symbol, a reminder that not all questions must be answered right away. Some are meant to stay open like windows to the vast unknown. There were children who would grow up under those lessons. Kids who sat under planetarium domes, eyes wide, listening to stories about the comet that glowed green without reason. They would go home and stare at the night sky, wondering if maybe the universe was full of gentle secrets just waiting for the right person to notice them. Years later, one of those children, grown, determined, curious, would sit at a computer console at ESA's newest deep space observatory. The data feed would flash a small alert, a faint hydrogen spike, frequency close to the hydrogen line, source uncertain. The analyst would hesitate, remembering something from an old documentary. A voice, soft and amused, saying, "It may not have been life, but maybe it was a reminder of what life does. It moves." They'd smile, save the data, flag it for further observation. And then, without really knowing why, they'd whisper, "Welcome back." Because maybe it was nothing, or maybe it was the beginning of something new. Maybe Atlas had never left at all. Maybe all along it had been part of a cycle of learning, of reminding, of returning. And maybe that's the quiet truth behind every mystery that ever crossed our sky. Not that the unknown comes to challenge us, but to teach us, to slow down, to look closer, to remember that curiosity is not chaos. It's harmony. The stars twinkled in silence, and the black between them seemed just a little less empty. Somewhere out there, a grain of nickel dust from a long-dead comet shimmered faintly as it tumbled through space, its particles catching starlight, scattering it in all directions. If you could listen closely enough, maybe you'd hear it. Not words, not signals, just a rhythm. Slow, steady, ancient. The same rhythm that guides comets, moves oceans and beats within every heart that has ever looked up and wondered what if. And as the night stretched on, the earth kept spinning beneath it, billions of tiny lives, countless dreams, endless questions. All of them are part of the same quiet conversation. No transmissions, no messages, just connection, written in light, water, and time. The universe didn't need to explain itself. It already has. Through 3i Atlas, through us, through every moment of stillness that made us look up and listen.